All right, so the program for today, we're going to take a look at network policies with ArgoCD and Otterize. So it's going to be a full hands-on webinar or hands-on lab, if you wish. The goal is really for you to get an overview on how we can achieve that with Otterize, how to manage the lifecycle of network policies, and automate the deployment of that with ArgoCD. And I've also included another component, which is more around how to manage workflow approvals and things people can do with client intents, because you don't necessarily want to directly allow anyone to push client intents on any repository. So for that, we're going to be using Kyverno. So, but before going into more details, a quick introduction of myself. My name is Nick. I've been at Otterize now for about 6 months or so, but yeah, before that, I've got a lot of experience with Kubernetes with different companies, large size companies, small startups as well. But I've been essentially doing Kubernetes related activities for the last 7 years, whether it was on the network side, the storage side, security, now with Otterize, all those kind of things. And yeah, on top of that, in my personal life, I enjoy running. I'm also a distance runner, so always happy for people to connect with me on Strava as well. Okay, so let's get going. So for people who don't know what Otterize do, well, Otterize has the goal of managing the lifecycle of identity and access controls for workloads. So IAM for workloads. So what does that mean is that we want to automate access to resources regardless of the technology you use underneath. So it can be network policies, as we're going to see today, but it can be Istio authorization policies. It can be managing database credentials. It can be managing, access control list for Kafka and other application, or managing IAM for cloud workloads. So the idea is really to find to propose a unified framework to manage all those components with a single methodology, a single resource. And this methodology is called IBAC, or Intent-Based Access Control. So the idea is like for iOS applications or Android applications, when a developer needs to access specific device capabilities, well, it just fill a specific file, info.plist, for example, where it just specifies what they need to make their application work. And we want to make the same thing for IAM. So now, instead of think about not device capabilities, but what your application needs to call to function properly. And so for today, we're going to take an example of an application, a microservice application based on what we call in France the Shifumi game, which is a rock, paper, and scissors game. So this game, I've deployed it into a microservices application, as I said, and we're going to take a look at the architecture there. And so we have one client. The client is reachable by the user and exposes an API/play. And when the user reaches that API, it can specify his choice, then the session ID next, when the game goes on, and everything gets put on the client side in a Kafka topic called client choices. And on the server side, the role of the servers is to compute the game results, right? It's a distributed game, meaning that one player plays on his computer, another plays on another computer, and they communicate by using Kafka, right? So we have the client side Kafka, where there are all the choices, and the game results, which is computed by the server and sent to the game result Kafka topic. And then the client also check this specific Kafka topic for the next round, so that the player can play the next round with updated information. And so how are we going to deploy that application? So the goal really for us is going to be to secure that particular application. So as you see, there are three main components. There's the client, there's a server, and there is Kafka. But we need more than that. If we consider, let's say, a staging environment, we would need things like like an infra as code repository where we can get extra policies, extra tools to make that application work. So for managing the lifecycle of that application, we're going to be using ArgoCD. So ArgoCD will give us the ability to leverage a GitOps workflow. So what that means is that our code is sitting on a Git repository. So in our case, this is the Shifumi app and the Kafka. So those are actually in the same repository, but in different directories. So the good thing with ArgoCD is that it's natively compatible with Customize. And with Customize, you just specify a particular directory where you have your overlay. So an overlay is just an environment configuration. Can be prod, can be dev, staging, all those kind of environments. And then you just specify the directory of these customization files to ArgoCD, and it will deploy as requested in that directory. So we have a single repository, but we have one customization folder for the Shifumi app and one customization folder for Kafka. So that's essentially compose our main application. Then we want also to add additional features to our application. So we want to secure it. This is where we want to store our client intents. So as I was saying earlier, client intents can manage a lot of different lower level IAM techniques. But for today, yeah, it's going to be network policy. So the client intents are going to represent in the same way we've just seen that the XML file was representing the capabilities an iOS developer needs to make their application work. Here, we're just specifying the calls that the application needs to function properly. So essentially, it means that from the Shifumi app, I need to access Kafka, all those sort of calls we're going to see in a minute in details. And then I also want to include more, let's say, compliance policy in terms of what client intents can cover. Because by default, anyone that has access to the client intents, so protected by traditional Kubernetes or back, well, you just define your client intent. If you have access to that resource, then it's going to be applied into your cluster, right? So typically, we trust the people who are, who have access to that particular client intents because we have already this layer of RBAC. So the first thing is always, you have to make sure your RBAC configuration is on point, right? But on top of that, we also want to check statically in terms of syntax what you're allowed to do with those client intents. So for today, we're going to make sure that any code that is done by a client cannot be made to a namespace that is in production. So the calls that we want to make cannot be destined to the production namespace. And statically, we're going to make sure by using a Kaiverno policy that we're going to see in a moment as well. So we have two things that we're going to update, right? Because the idea of ArgoCD is that it can react upon Git events. So typically, we're going to update our Shifumi application. And then dynamically, when I say update, we're going to commit a new code into our repository for the Shifumi app. And as ArgoCD detects that, it's going to deploy the new version of that application in the cluster. So GitOps workflow also makes sure that there is no human interaction for better security. So no one has to log into Kubernetes to deploy the new version. We rely on an automated process, on a GitOps workflow to do that. So that's the first part you want to update, and you want ArgoCD to react on that. But the second one is also the policy updates. So the policy update is as you define new traffic in your application, new services, then the policy need also to be updated, right? That's a second thing where ArgoCD needs to react. And ultimately, when you go to production, of course, normally you just deploy once, and then everything that has to be updated is updated at once. So the application update and the policy update, all of that should be triggered at once. But here the idea is we are not yet in production, so we are testing out the flows. We want to do our application dependency mapping so that in production, we can be sure that we are relying on the least privilege principle. Right. And the only thing I didn't mention is how we're going to build this, this configuration in ArgoCD. So we're going to be using a pattern that is called the app of apps. So the idea is that from a single high-level, application, that application, so when I say application, it's a custom resource in ArgoCD. So we define the parent application, which is Shifumi deployer, and that application will be composed of other applications, right? So in the Shifumi deployer, we're going to create another application called Shifumi app, Kafka, client instance, and Evernote policies, right? So why are we doing this? Is because now we only have to deploy the parent app. And once we deploy the parent app, we're going to see in ArgoCD automatically, right? Because this app contains the other ones are going to be deployed. And if you were to make any choice, any change manually to the children application, then because of course we're relying on Git to be the single source of truth, the changes would be reverted, right? So you have to make sure that when you deploy, when you update, you deploy either from the Shifumi deployer, the parent app, or you specify exceptions to not monitor. And we're going to do that just in a moment as well, because we're going to be changing the code, update the code, and we don't want the parent app to rewrite this to the previous version. Okay, so now let's jump into code. Okay, so here we have our environment. On the left-hand side, this is ArgoCD. And within ArgoCD, you can see at the moment, I don't have any application defined. Here we have Otterize Cloud. So I've already connected the cluster on the right to that environment. And the particular namespaces I'm going to monitor is the Shifumi and the Kafka, where the application is going to be deployed. And then here I've got my different repository. So first, let's take a look at this one. Let's take a look at the deployer, right? So the deployer here is the ArgoCD application that contains the definition of all the children's application. So the main one, like the parent application is Shifumi deployer. Here I just define the repo URL, which is exactly that one. The target revision, I want to be on head. The destination, so it's going to be basically my local cluster here on the right. And that's basically it, right? So here I'm just specifying that this is the parent app. And because it's compatible with customize, right? Remember, ArgoCD, you can just apply customize manifest to it. I just specify the path to deploy all my other application, right? So here, if I go into apps, that folder, this is where I define the children application, right? So I have my Shifumi app, which correspond to the repo of my Shifumi game application. I've got the Kafka, but in the path is the overlay for Shifumi, right? Now, in terms of the Kafka YAML, it's exactly the same repo, so the Shifumi game, but this time the overlay is the one that corresponds to Kafka. So effectively, it's going to be deploying Kafka for me. And then I've got the two other repositories. I have the client intent. So the client intent repo, we're going to see there in a moment, contain all the client intents for my application to work. And there are actually two options for you to create client intents. So first, let's maybe take a look at what client intents looks like. They are in the policies here on the left. So the client intent, as I said, is just a list of calls. So for example, here our Shifumi client, remember in the application architecture, just needs to call Kafka, right? So we define Kafka here. And here, for example, the Shifumi server just need to call Kafka. And we also have other components here, but I didn't generate, I didn't create them manually, because of course, to deploy Kafka, we need an operator. So that operator is a container. It's also a pod that needs to call specific component in the application to make Kafka work. But there's two solutions usually. Either if you deploy an operator or solution like ArgoCD or other software, they come defined with predefined network policies, and you don't have to manage them. It's just managed out of the box, because as you deploy the application, it will be deployed with network policies. If you don't have network policies, then what you can do is rely on Otterize to detect the traffic, detect the different calls, and actually generate the client intent for you. We're going to do it in a minute, but here I needed to start with something. So I've already done the job beforehand. I've deployed my application. I've used Otterize CLI to generate the client intent, right? And then I've added this client intent into my policy repository. So this is why it's not empty, but we're going to do it again manually to show you. And then I've got the Kyverno policies. So the only thing that Kyverno policy is doing is just statical check with a regular expression that whatever I place into the call section of my client intent. So you can see the list of calls, for example, like it's calling Kubernetes in the namespace default and Shifumi Kafka. Well, here I'm going to be doing exactly the same thing, but let me go back to the repo. Sorry. Here in the Kyverno, the policy here is going to match this calls property and make sure that anything that contains .prod will be denied on that particular condition. So to do this, Kyverno is relying on an admission controller, a validation admission controller. So when ArgoCD or a human being is trying to apply a manifest to a cluster, then Kyverno or the Kyverno admission controller will check with a webhook before it's getting applied to the cluster. It will check that the manifest effectively matches your policies, what you have defined in your Kyverno policies. So it's very, very powerful. It can do many, many different things, check image signature. But for today, it's rather simple. We just want to make sure that whatever we deploy into our dev or staging namespace cannot call anything in the production namespace, right? That's an easy way to do it. All right. So if we go back to I think we cover pretty much everything into the deployer. So we have covered the parent app, we have covered the children app. Yeah, and we need the customization. So the customization file is just listing what you want to include for ArgoCD to deploy, right? So we have the Shifumi deployer that refer to the apps path. So we are just defining apps directory into the Shifumi deployer, into the parent app. And into this apps directory, we are setting all the others ArgoCD application and then we are listing them into the customization file, right? So, and the next step will be for us to deploy that application, right? So to deploy that application, I just need, so here it's the same thing, right? If I do tree, this is my current repo, right? So I just have to do kubectl apply-f of my current YAML file here. And as we do that, we will see on the left, the application is going to pop up if everything works well. Hopefully, it's not going to be the demo effect. I've tried 100 times before, but we never know. So we're going to see here the parent application and the children application getting deployed. We're going to see in a minute also something in Otterize. And here we can already see, like here, the Shifumi namespace has been deployed right now, and Kafka is actually being deployed as well. All right, so we're going to wait a minute. And here on the left, we can already see in Otterize Cloud that is connected to that particular cluster. So you can see here on at the bottom, I've got my Otterize system namespace where I have the three main components of Otterize: the credential operator, the intent operator, and the network mapper that will help us map real traffic to our network policies and client intent. So I can refresh here. So I have everything discovered. So this is my final application, how it looks like, as detected by Otterize, but also because I have the client intent, remember. So now if I go in the client intent list, you can see that I have all the client intent sitting in my repository that have been deployed. And if I go to ArgoCD, so normally I should have here pretty much, yeah, everything has been synchronized. And what is nice here, if you go on ArgoCD, you can check, all the different manifest, the desire manifest, the live manifest, if there is any difference in that. But currently, it should be just a mirror of what was in my repository, right? I didn't change anything. So everything has been deployed. Everything is green. So now let's see a couple of things on the access graph here, and also what kind of network policy we have generated. So if we take a look at the application flow here, we can see that, as I mentioned in my diagram before, we have the Shifumi client wanted to connect to the Shifumi Kafka, Shifumi server to Kafka. And then we have a couple of other components, right? We have the Streamzy cluster operator, the Kafka entity operator, and the Kubernetes, essentially the Kubernetes API, right, in the default namespace that needs access from my operator, right? And Kafka needs basically to access itself, all right? So now if within this view, I can also go to some of the nodes. So for example, here I see the client intent that needs to be applied to make the traffic happen. So here I'm also checking assume default deny. So I'm assuming here that I've got a default deny everywhere. So I need to see a green arrow for the traffic to happen. Now, if the arrow was red, it would mean that if I was to deploy a default deny, or if I have applied a default deny already, my traffic would be blocked or is already blocked, right? If I have the default deny. So it's like, let's assume that you have a default deny regardless of if there is an actual default deny in your configuration. So if you don't have any default deny, it's just to make sure that, okay, if you want to apply a default deny, this is what's going to happen, right? Be careful. And if you have the default deny, well, it just means that you have live monitoring of your environment, right? And on the server side, I can see also here, for example, all the clients on the left and the global client intent that this server needs to be functional, right? So it's very, very useful. Now we can also, before checking the network policy, let's generate some traffic, right? So for this, we're going to go into the pods view. I'm going to have to quickly here forward my client and my server. So what I'm going to do, I'm going to be just playing, let's say, one. Normally it's 3 rounds, but we're going to be just using 1 round. So 1 round, I'm posting to my redirected port here locally for play, and I want to choose rock. I don't need a session because I'm the first player to join. So normally it should be, yeah, intelligent enough to notice that it's the first player. Now I've got a session ID. So let's join also as a, normally I don't need a session yet because I'm the second player, I believe. No, I think I need one. Right, let's do that. Scissors, and we need, of course, to change the session ID with the one that has been created for us. Okay, so choice has been submitted. So on the server side now, if I go into the logs of the server, I should see, yeah, the results. So on this particular round, it's player 1 that is winning because Stone is beating Scissors, right? So that's the first round now. Well, it's just to generate some traffic. So why I'm doing this is because of course, I've got my client intent that I've applied, that I've defined my application map, right? But if while running my application, Otterize can detect maybe unexpected traffic. So just by generating traffic for your application, we would be able to notice new application flows here, right? And there's also, but here we don't have any other flows because the application has been defined properly because I've used Otterize Mapper. So Otterize Mapper is a CLI where you can do a lot of things. You can visualize the policy. So I didn't mention, but Otterize is fully open source. That's pretty obvious, but also the cloud. You can just register if you want to connect your cluster to the cloud, and you will have, more integration like the GitHub integration, Slack integration, all those kind of things. But it's also open source, right? I mean, no, it's not open source, it's free. The code itself of the our SaaS platform is not available, but it's free. You can just register. And at some point, of course, if you need to run it in production, you will have to give us some money, obviously, for support. Okay, but my point here was you can start without cloud. And remember, it's the network mapper pod that is detecting the traffic that is flowing into the cluster. And the Otterize CLI here, Otterize Mapper or Otterize Network Mapper, is interacting with the network mapper in your cluster. So if I do that, it's basically generating the network, the client intent. The same thing I had in the repository before can be now just used as part of my CLI. Is basically given by my CLI. And what I can do now is also pipe this to my intent, which is exactly what I did to get my client intent. So just so it's exactly the same thing as we have on the GitHub repository, right? So this is where we have all our flows that is corresponding to the flows on the left here, right? So that the ID. So now let's check maybe the network policies that have been created. So the big difference between network policies and client intents is the direction. So don't pay attention to the ArgoCD network policies. It's not managed by Otterize, because remember I told you many of the applications today that you deploy via Helm or customize or whatever, they come, if they are bundled, they often come with predefined network policies, and those network policies are just deployed as part of the application. So for example, here, yeah, it's already defined, like matching ingress from ArgoCD server on those ports, etc., etc. So you basically don't have to touch them. Yeah, it's just part of the application package. So this you don't have to manage with Otterize, right? What we are managing with Otterize here is only this network policy. So we have different client intents that translate into a single network policy. So why is that? Is because remember, network policy, we define them at the destination. So here the destination in the namespace Kafka is the Shifumi Kafka access. So it is basically ingress to Kafka in the Kafka namespace, acting as a firewall on the server side. What should I allow? I should allow, as per defined in the diagram, anything that is coming from the Shifumi client or the Shifumi server or Kafka entity operator or Streamzy cluster operator. So how do we do this with Otterize? Well, we just relabel everything, right? So if you check here, ingress, we should, for Kafka, right, metadata name matching from the Kafka namespace is with this. So any pod that has this particular label in the Kafka namespace will be allowed access to Kafka, right? And in the same way, any pod that has this label, so access Shifumi Kafka true in the Shifumi namespace, right, will have access to Kafka. So now, of course, if I check the label into my different pods, let's say the Shifumi client, so Shifumi client here, I check one of the label, of course, I can find the same label here, access Shifumi Kafka true, right? It's the same thing for the other pods. So this is how we essentially automate using client intent, right? So yeah, if you have any question, just type here. I will monitor as we go as well. So hopefully it's clear enough. So this is how we generate the network policies. So now what I want to show you is what happens. So now essentially it means that we have the network policies, everything is green, our application is working, the client can talk, the game is working, we've seen the result into the logs. So everything is fine. So now what happens if I want to change my application and I don't have the client intent? Like if you were to start with a new component, how do you start from scratch? Well, it's just the same principle again. Now the difference is that we're going to change the application and ArgoCD set. Let's do it from the other screen. I think it was recorded before. So what I'm going to do by doing this, so ArgoCD app set, it's the same as if I was going into the UI and I'm going to change, remember the Shifumi app here. I've also specified for the parent application to ignore any change I'm doing here. So what I'm going to do here, instead of using that revision, that particular branch, I'm going to be using another branch that is called logger. And when I'm going to do that, it's going to deploy a new service, a new version of the application, which will include a logger trying to access the Shifumi server. We're going to see that normally the arrow should be red. So cross finger should work. Okay, let's check that the application logger. So the logger have been deployed here. It's going to take maybe 30 seconds to 1 minute to reflect in the cloud, but normally the logger should be starting to work because also something I didn't mention, but which is quite important to understand what is happening here. Why is the logger able to connect to the resource it needs? We're going to see the logger is going to be connecting to the Shifumi server, I believe, in a moment in the cloud. So why is it able to connect without any network policies? Well, it's because on the Shifumi server, remember, I don't have any network policies. The network policies currently are defined in Shifumi Kafka, right? We have the client intent defined on the client side, but network policies are defined on the server side. And there is one thing you have to understand about network policies is that once you have created a network policy, and actually this is the challenge of network policies, is once you have created, oh, it's there, fresh, yeah, you can see it here now. Once you have created a network policy on the server side, anything that needs to access the server needs to have a network policy as well. So imagine if I had like another service trying to reach out Kafka somewhere in another namespace, and it was working before I've applied the network policy, right? Now I've deployed this network policy through client intent, which means that I have a default deny for that particular pods matching that network policy by default. I've got this default deny now. So if I didn't have a network policy, if I don't have a network policy to access that server now, it won't work. It's going to block. So prior to the network policy, my server somewhere, maybe in another NetSpace, had access to Kafka. But now, if I don't define any network policy, it's going to be blocked, right? So that's the idea of network policies. And this is why it's very difficult to manage, because the moment you deploy a network policy for one target, this target needs network policies to enable access for every potential source, right? So it's a one-off sort of button. So this is why it's good to deploy Otterize in non-enforcing mode first, which means that no network policy are going to be enforced, but you will be able to leverage all the client intent and all the different, application mapping. So it's a good idea to do that first, and then go service by service so that you understand what network policies needs to be created. But it's a lot easier to manage this on the client side using client intent. And this is why we use client intent in IBAC, is to simplify the management of destination, change the ID from the point of view of the developer. What do I need to make my application work? The rest is just a byproduct of that. Okay, so back to the point, why do I have access to, can I access the Shifumi server? Well, it's because the Shifumi server doesn't have any network policy applied, right? Because until now, no one needed to get access to my Shifumi server, right? I just needed access to my Kafka. So this is why it can effectively, the logger can access the Shifumi server. It's because it's a free lunch, right? I don't have any network policies. But if I was to have a default deny on the entire namespace, then it would be blocked. This is why this screen is quite useful, right? If I don't assume default deny here, it's going to turn green, right? If I assume default deny, I don't have any client intent defined, right? So the good thing is also now the logger is telling you, well, if you want to make logger work, you would need this particular client intent. And you can see here, it's seen in discover traffic, but not declared in client intent. So Otterize has already detected that the the logger was trying to access the Shifumi server, but the policy is not there. So if you were to enable the default deny on the entire namespace, this call would be blocked. So what I need to do now is I need to update my client intents on the Git repository, right? If you look at them, again, here, I don't have any, if you look at here, right? Let's put a bit more space. I don't have any logger, right? So what I want to do, I'm just checking that I don't have anything, everything is clean here. I want to use Otterize mapper again to my client intent, right? If I do that, I should see I've got a difference. If I do a git diff now, I would see as, Otterize Cloud, because Otterize Cloud is also leveraging the network mapper and reporting it into the cloud. Our mapper has basically told us, now you need the logger client intent to make this call, basically this arrow green, right? So now, because I'm managing everything through ArgoCD, I want to deploy that into ArgoCD. So there's different way we can do that. There is also an integration of Otterize with GitHub, and on GitHub you can, so Otterize, when detecting new calls for an existing service, right? Detecting new call for an existing service, we can create a pull request, and then someone can merge it, or you can just auto-merge. Auto-merge creates a Git event, and then in turn, in ArgoCD, it will automatically be deployed. So if you want to wish so, if you wish so, sorry, let's say if you are in dev environment, you can automate everything from the detection of the new call to the deployment of the client intent. You can have everything like automated. You don't have to do anything to have client intent deployed into your cluster. Here, it's a new service, like we have the new logger service. So we can't create automatically a pull request at the moment. So what I need to do is just run. I mean, you could automate it as well, right? You can automate you can trigger the CLI and get the new client intent. So git add intent. So what I mean is what I'm doing manually here, you can easily automate that yourself. So I'm going to do git commit, just add the logger client. I'm going to do a git push. So if I do git push, it's going to be automatically and instantly deployed here in the client intent on ArgoCD. But why? It's because I've created a webhook between ArgoCD and GitHub, right? So GitHub is sending a special JSON payload to ArgoCD. ArgoCD will take that message and basically upon that message will sync the appropriate application, right? It's very easy to set up, but why I did this is because I didn't want to have to sync manually or wait for the next sync. So I want like a instant reaction so that when I hit push or when the PR merge, my application is updated instantly into the cluster. So now if once I'm going to do that, if we go back here, we should see, before validating, I'm just going to check the client intent. I should see a new intent for my logger if everything goes well. So git push, cross finger, everyone. So yeah, syncing here, and it's there, right? So now my access graph should turn green, right? So I have now my client intent defined. So which means that now I should also see a new network policy. And I can see it here, right? The Shifumi 1, 20 second, right? So what does it contain? Well, as you can imagine, the same pattern, design pattern as we've seen before. We are creating a new label. So access Shifumi server to true. And then we're going to be labeling the logger with that particular label. And now it's going to have access to the Shifumi server. Right, as easy as that. Okay. And I think that's pretty much it for that part. Now, what I want to show you is also how to manage some sort of access policies for client intent, like how what you can or cannot do with client intent in terms of statistic analysis, like if you want to prevent specific regular expression within the client intent manifest. So if we go back to the client intent on the top here, take whatever, like let's say the Shifumi logger, that was the last one. It's an easy one, right? So that guy here, he wants to call the Shifumi server and from service name logger. So of course, you may want to exclude certain pattern here. So remember I said at Otterize, it's not only about network policies, right? It can be different layer, operating at different layer of the OSI model. So network policies, it's a networking feature, layer 3, layer 4, fine. We can have Istio authorization policy, which will have a different naming here. We will have like HTTP just in the call type, right? So it will be a different convention. We can have call to AWS, which will be calls type AWS. Same thing with Azure, same thing with Kafka, right? So there are a variety of a more specific security domain we are managing with client intent and IBAC. Therefore, you may want to limit what people can do, right? And an easy way to do this is by using Kyverno, right? So again, I'm just going to check I'm just going to go into Kyverno here. So this is the same repository as before, as I showed you on GitHub. What I want to do in Kyverno, all right, so matching the calls, so all the calls, which mean that I need to loop because the calls, it's an array of calls. I can have more than one call. So I want to check that for every call part of the list of the calls, I want to match special condition and deny specific condition. So if I take my simple example here, of course, you can do very more, like complex things, I would say. I want to deny the service that end with .prod, which means that essentially they will be in the prod namespace. So you specify the regex match here, and here means any character multiple times, then followed by .prod, and finishing with end of line. And element name, which because I'm looping through the for each, right? That's the current line I'm looping into. So the element name for that particular line I'm looping into should not contain .prod, right? Because operator equal true. So if this is true, if I have prod in the name, then I want to deny, right? That's rather a simple policy. So the only thing you have to do after that is just apply, but remember, apply that policy. That policy is already applied because remember, right, is part of our application. It's the Kyverno policies. And if I go there into details, again, the manifests, it's an ArgoCD application. This is the kind, and this is my app policy repository in the Kyverno directory. I'm in the Kyverno directory here, right? So this is why it's already there. In terms of the resource that is deployed, custom resource, if you check Kyverno here, right? So you have the one I've been using, the kind is cluster policy. So cluster policy, edit this one, is exactly what I've told you, right? So this policy is already in place. So now what we can do is describe, and I'm going to toggle auto refresh. So now I'm going to try to modify the client intent so from the logger here, I want to access prod, right? So let's say now I'm trying to access, I made a mistake. Instead of, connecting to my dev environment, my local environment, I'm trying to connect to prod, which obviously you don't want to allow. So git diff, just to be sure, right? Of just this line. So now, again, we don't deploy anything in the cluster. We're using ArgoCD, we're using GitOps, right? So here, I'm just gonna, again, git add the intent, git commit. I'm removing, or let's say, we say add prod. Okay, so I'm gonna do git push. And what should happen first is that I should see like trying to sync in the Kyverno policies here, not Kyverno, I should see a new sync in the client intent, but it should not be deployed, right? If I do git push, I should see at some point an event here because Kyverno will reject my update, right? So let's hope it's gonna work. Pushing. Okay, so you can see here, validation failure, calls to service in the prod namespace are not allowed. So if I go to the client intent again, right? So logger should have changed, right? It's still, it's still Shifumi server, not the one in production. So of course now I have another problem, right? Because so Kyverno, the admission controller, deny my update. So the client intent here, ArgoCD, is going to try to deploy again and again and again, right? Until it can check the desired state with what is effectively running the cluster, with the current state in the cluster. But the current state of the cluster will never match the desired state because we have Kyverno as a guardrail, right? So that was basically the last part. So we have a full functioning application now. So I've shown you from how to deploy the application with ArgoCD. I've shown you the app of apps pattern. I've shown you how we generate network policy. I've showed you the Otterize CLI, I've showed you the Kyverno policies. So I think we are good to go, and we have a couple of minutes left. So let me switch back to the presentation quickly, just to give you a couple of more information. So again, if you have any questions in chats, I'll be more than happy to answer. If not, or if you want, maybe you will have questions later. So the first of all, you can reach me on our community Slack. The link is the next slide. If you are interested by doing this yourself, you can try out this Discovery Lab that is including exactly the same thing I've mentioned today. So the same application will go through the same thing, not the GitOps part, but just to get a bit familiar with the network policies, how they are generated, all these kind of things. If you want to try it in your cluster, then we have tons of tutorials on our websites, and that will be very useful for you. And then finally, if you want to join the Slack channel, that would be great. So we can get our conversation going. If you have any questions or any use case you can think of, please feel free to ping me there. And with that said, thank you for joining today. That was a pleasure to be your host. Again, if there are any questions, feel free to ask them. If not, well, I'll see you soon.